warm welcome to another interesting session on Learn with Labtech channel. So our today's topic of discussion is thermal mass flow meter. This is our thermal gas mass flow meter, and here we'll be seeing about the operations, overview, structure, the principle, applications and operations of this meter. So this is thermal gas mass flow meter, and the technical specification of this flow meter, specifically the temperature 150 degrees Celsius and the pressure 1.6 megapascal, and the size of the line size DN25. The flow range is 175 Newton meter cube per hour, and the accuracy is 1.5%. Power supply is 24 volt DC. Let's see the overview first. This thermal gas mass flow meters are instrument that measures the mass flow of gases. So we know what is mass. So mass is volume into density. That means our volumetric flow rate, which we measure in meter cube per hour, when we multiply it by the density of the fluid, which we'll measure in kilogram per meter cube. So that we'll get the mass flow rate, that is kilogram per hour or kilogram per second or even ton per hour. We have two types of structure. One is flange type and other is insertion type. This is the flange type thermal gas mass flow meter, and there's an inlet valve where you can give the combustion air or means of any gases. So the structure consists of two sensors. One is velocity sensor, another is temperature sensor. So the main principle here is it sends the temperature of the gas being measured. It works on the principle of heat transfer principle. So as the gas mass flow rate increases, the airflow takes more heat and then the temperature of the sensor decreases. So here we use 1 inch, that is DN25. This is the pipe segment type, as I have told you earlier, flange type. The main application is it's the multi-component gas measurements like oxygen, nitrogen, hydrogen, chlorine, blast furnace gas, and so on. Even it's used for flow measurement of underground ventilation or exhaust system. This is a display unit, and here we have the three menus. First is the enter key. This is to enter or return to the main interface of the screen, and this is shifting, and this is turning or addition. So in the display, having the cumulative flow in Newton meter cube, and the next one is instant flow Newton meter cube per hour, and this is velocity meter per second, and this is output correspondence voltage. This is the initial condition. You can see that the cumulative flow is 0.3, initial flow, instant flow 2.8, and the velocity 1.6, voltage 0.7. We'll just do an experiment of giving a compressed air inside the inlet valve. Let's see how the value changes from the initial to the correspondings. Let's check with compressed air. We are testing with compressed air. You can see the changes here. In instant flow, it gradually changes. The compressed air given is 20 psi. You can see the changes. 5.6 Newton meter cube per hour. Velocity 3.4 meter per second. When the compressed air flow increases, we can see that the instant flow 11.262 Newton meter cube per hour, and the velocity 6.49 velocity meter per second. This is the main interface, and I have told about the keys. To enter into each menu, you can give this enter key. I'm just entering. First, it will ask for password. So let me give the password first. I have set the password, and then this is the medium set. You can set anything like hydrogen, oxygen, nitrogen. The value depends from 0, 0, 1, 0, 2 for oxygen. It depends. Initially, I gave the medium as compressed air into the inlet flow, and then unit. Unit displays in Newton meter cube per hour for instant flow, and you can say set depends like Newton meter cube per meter, kg per hour, kg per meter. In that way, you can set, and this is minimum k value, maximum value, and it goes damping. Damping set you can set within 0 to 500 seconds, and this is a diameter. So I've told that this thermal gas mass flow meter is 1 inch. That's DN25. So we have so many menus here. So this is our final interface. I mean, like, this is our main interface. We have seen that giving the compressed air, how the value changes here in the main interface. Finally, the technical advantage of thermal gas mass flow meter, it has digital design, it gives an accurate measurement, and the display has the mass flow rate, standard volume flow rate, cumulative flow rate, and standard flow rate. Thanks for watching our channel. We'll come back with another interesting video. Thank you.